Okay, so today we're going to be reviewing all the different stat things. So this is our stats review. So the first thing we're going to talk about is the patterns of association. So these are just some scatter plots here, right? And there's the 4 types of associations. There's the positive linear, negative linear, nonlinear, and no association. So they should be pretty self-explanatory, right? Positive would be going, think slope dude, right? If they're going up in a linear fashion from left to right, that'd be positive, right? Positive, puff, puff, positive, right? And then nice negatives where it's going downhill from left to right. Non-linears if it curves, and no association, it's not forming any kind of line at all. It's just a blob of points. So when we look at these, this first one would be the positive linear run, right? It is going up from left to right, so positive linear, puff, puff, positive. This one is the negative linear. It is going down from left to right, so negative linear. This one is also negative linear because it is going down from left to right, and this one would be positive linear, right? It's not too tough. Going uphill, downhill. This one curves, right? We got a bit of a curve here. So this is a nonlinear example. Okay, anytime it curves at all, that would be nonlinear. And this last one is just kind of a blob, so this is the no association. Okay, and that's all you're doing for those first few problems. You're just identifying which of the 4 types it is. Okay, then the next problem we have is the line of best fit. So this is where we try to figure out like the average of a bunch of points by drawing a line through the middle of them, right? And then we find a slope and a y-intercept. Again, the equation we're looking for is y equals mx plus b, where m is your slope and b is the y-intercept. Okay, so first of all, let's find that y-intercept. So we look, this graph isn't amazing because it's going up by 16ths. And that's hitting about halfway. So we're going to say it's 8, but that's just a guess, right? Because I can't actually see that. So we're going to guess on this one that it's 8. Okay? And then to find our slope, we're looking for 2 points where it hits an intersection on the grid. It looks like it hits an intersection right there. And then the next point it hits, it looks like it hits this point right here. Okay, and I'm going to pause. Okay, sorry, there was an announcement. Okay, so I found 2 points where they hit an intersection on the grid. So this is where we count the rise and we put it over the run, right? And it is important to pay attention to the scale. How much we're going over is dependent on the scale, not just the number of blocks. Because each block going up is 16, right? And each block going over is going to be 3. So when we look, this goes up 3 blocks, so 16 times 3 would be 8 times 6 would be 48, right? Yeah, 48. So I go up 48. Then I go over 1, 2, 3, 4, 5, and that's going by 3s, so that would be 15. So my slope, where's my calculator? My slope would be 48 over 15, which simplifies to 16 over 5. Okay, so 16 over 5 would be my slope. Okay, then I need to write a prediction function for that. So basically I'm just putting that all together into the formula for a line. So I'm just replacing the m with what I got and the b with what I got. So y equals 16 over 5x plus 8. Okay, then it's going to ask me some questions about what the slope and stuff are representing. So the slope is my y values over my x, right? Well, in this graph, the y values are representing the dog's weight, so the number of pounds, right? And the x-axis is representing the dog's height. So we would always just say whatever the y is per whatever the x is, because it's y over x, right? So this would be weight per height. That is how we want you to set that up, and basically how it would be formulated each time. Okay, weight per height. Whatever the y is representing per whatever the x is representing is basically what the slope represents in context. Okay, then it's going to want me to predict the height that the dog, if the dog weighs 70 pounds. So it's going to give me a y value. So I'm going to plug in 70 in for the y. And I'm going to have to predict what the x would be. So 16 over 5x plus 8. So it's just a two-step equation, right? I'm going to minus 8 to each side. Minus 8 gives me 62 is equal to 16 over 5x. And then I could do this a couple ways. I could times by 5, then divide by 16, or I can just divide by 16 over 5 to each side. Since my calculator has a fraction button, I can do that. So I'm going to do 62 divided by 16 over 5. And I get 155 over 8, or as a decimal, that'd be 19.375. Okay, so the x, it would be about the height would be, am I doing this right? Did I do that backwards? No, I did it right. So the height would be about 19.375. If we round that to the nearest whole number, we would say it would be approximately 19 inches. Okay, either answer there is fine. Then we're going to predict the weight if it gives me a height of 15. So this time it gives me an x value. So I'm going to have y equals 16 over 5 times 15 plus 8. And I can just plug that in my calculator. So 16 over 5 times 15 plus 8 is 56. So if the dog is 15 inches tall, their weight is going to be around 56 pounds. So that's a pretty good sized dog there. Okay. Then, using the information graph, what is the relationship between the dog's height and weight? This is basically asking about the correlation or the association here. So it is a positive correlation, right? So you could write positive correlation. You could also actually describe it. So you could say the taller the dog, the more it weighs. Okay, and that's all it's really asking. Okay, let's do another one of those. So let's see if this one doesn't come down to a fraction. Okay, so this one, the y-intercept is much more clear, right? The scale here is it's going up by 5 each time, so it hits right here at 35, so the y-intercept would be 35. Okay, that's a little bit more clear. The next thing we're going to look for is 2 points where it hits an intersection on a grid. So it hits right there. The next time it hits an intersection, I don't actually see a nice intersection. So we're going to say, again, these are lines that we drew in, so they're not going to be great. So let's say it's hitting every intersection. I know it isn't because it kind of slips a little bit on that line. But let's say it's hitting every intersection. It'd be going down 5. So negative 5. And it'd be going over, the x is going by 12s. So your slope would be negative 5 over 12. Okay? So then to write my equation, the prediction function, again, It's just the y equals mx plus b. We're just replacing the m and the b with these numbers. So y equals negative 5 over 12x plus 35. Okay, what is the slope represent in context? Well, again, that's the y per x, right? So the y is the average emails per day. And then, this is their age. Okay? So I'm guessing this is average emails and then the age. It's kind of not written very well, but I would say average emails per age would be how I would set that up. Average emails per age. Apparently, the older you get, the less emails you get. I don't know if that's true anymore. This is probably a dated graph. Anyway, so next it wants me to predict a person's age if they send the number of emails they send. Okay, that makes more sense. So this is emails sent, and then age. Okay, and the sent is a missing key there. All right, so predict the age of a person if they send an average of 8 emails a day. So they are sending, this would be the y values, right? So 8 would be the y. And so, yeah, we are predicting the age. So negative 5 over 12 times x plus 35. So first thing we're going to do is I'm going to minus 35 to each side. This is a two-step equation, right? It's going to be the same two steps every time. You minus the y-intercept each time and then divide by the slope. So 8 minus 35, and I don't know why I'm checking this on my calculator, but I am, negative 27 equals negative 5 over 12x. And then I would divide by the negative 5 over 12. Again, since my calculator does fractions, I can do that. If I wanted to do it another way, I can multiply by the 12, then divide by negative 5. You're going to have the same answer. Okay, so if I do negative 27 divided by negative 5 over 12, I get 324 fifths, or as a decimal, 64.8. So x would equal 64.8, or if I round that to the nearest whole number, they'd be about 65 years old. Okay, so you are going to be about 65 if you send about 8 emails a day. So if we look on the graph, since this is going by 12, 65 would be like somewhere around here, right? Which is about where that line is, right there. That would be about 8, right? So that works. Fits my line. Okay. And then predict the average emails a person who is 14 will send every day. So we're going to plug in an x value this time. So y equals negative 5 over 12 times 14, because that's their age, right? That's what the x is, the age. And then plus 35. And then you just plug that into your calculator. So negative 5 over 12 times 14 plus 35 is going to be 29.16 repeating, or as the nearest whole number, that would be about 29 years old. Okay, so again, either answer would be acceptable there. Okay, and then using the graph, what is the relationship between the age and the emails per day? So that's a negative association, right? And basically looking at that, reading that graph, the older you are, the less emails you send. Yeah. Okay, and that's how you'd answer that one. So again, this is just the first half of the review. I'm going to split it up into 2 videos. So this is just the one on the line of best fit, and then we'll talk about frequency tables in the next video. So if you have any questions or concerns, ask us. We're here to help. As your teachers, we want to help. You just got to ask us. And I'll see you guys out there.